Welcome to Brain Vision.
For this problem, we're going to be finding the surface integral, and the general formula for that is this right here, where this is going to be f of r of u of v. So what we first want to find is f of x, y, z. We know that r is u cosine v, u sine v, v. So that tells us that our f of r u v, since we know that we'll eventually get to that, we will wait until later to evaluate that. Then we want to first find the partial derivative of r with respect to u, and that's going to give us a cosine v sine v 0, and then partial derivative of r with respect to v is going to give us a negative u sine v u cosine v 1. And then we take their cross product, and what we'll end up getting is the square root of 1 plus u squared. Then we want to use this information to plug into our double integral. So our double integral will look like this. The only difference is we can now go, since we know that u is between 0 and 1 and v is between 0 and pi, do this and 0 to 1. Then we know that this on the inside needs to be our f of x by z. So since it's just y, that means that we'll have u sine v, and then that's going to be times our cross product, so 1 plus u squared, and then that'll be, instead of ds, now we'll have du dv. Then we can separate these integrals. We'll put the v terms here, dv, and then we will get rid of this dv to get our answer. If we want to simplify this further, we realize that this will ultimately just be 0. What we'll get here is just 1, actually. So this will just be 1 times all this, so we'll get rid of that. And then this will end up giving us a 2u right here. With that in mind, we can now use the substitution method for what's inside here. We'll substitute that and evaluate our integral. And as a result of that, we'll end up getting that this is the same as 4 root 2 minus 2 over 3. And as we see, we get the same answer as we did in the beginning. So that tells us that we were correct in how we did this.